No.
Exactly. CH3, C3H3O. Good job. Be a DE agent. So the first thing you're going to do, you find an unknown substance and you're going to determine the grams of it. What's the amounts of different elements in it? That's step number one, which is what they've done. You have to do this to verify that it is that substance. Now today they have tests for it. Right? They can test, color test, reaction test. It'll tell you whether it is morphine or not. However, you know, if you wanted to do a purity test, this would be a way you could do that as well, determining the actual amount of carbon, hydrogen, oxygen, nitrogen present. So what's the next step you're going to do? Now you're going to add them all up to find the total mass. And then where's the total mass going to go? Think about a percent, right? You got the total divided by the actual. So whatever actual you had divided by the total times 100 is going to give you the percent. So then you go from the percent, just like we did here, and find the formula. Make sense? So that's the step that they left out here. Might want to do that. Is it 71? Okay, that's carbon. I'll do percent carbon like they showed you here on that one.
Why not just talk to her and see if she will?
She didn't even, like, I asked for help one day and she just...
I felt that way with Miss Smith. She'd always look at the ceiling and know all the carrots.
The carrots?
Oh, that's a carrot.
Okay, very good. So now what you're going to do, you're going to divide all of them by the smallest number. So divide all of them by 0.35.
Oh, it made me really mad. I passed her class with the lows, with the high side.
I understand why she hates me now, because one day she did that. I'm just like, you're not going to teach me, I'm just going to walk down to the classroom.
Garrett, write this down.
Okay.
No. What you're doing, you're going to divide all of them by 0.35. So this one will be 1. Does that make sense?
Yes.
Yeah, you saw me guessing on my test.
Good job.
Actually, I have my backup pencil that I sharpened in one try that you couldn't sharpen in like 10.
I'm not that bad.
Wow, 19.
Then why did it take him one try to sharpen?
Look at them ducks.
I've always had good luck with those type of sharpeners. As long as they're the white ones. Let me see.
All right, so here's your formula. Hello, from this, Garrett. This is your formula for morphine. So she's going to write it out now. It's going to be C what? C17. 5.96 divided by 0.35. Yeah, check it again. It's good to me. Yep. Yep. Kayla got that correct. The molecular formula referred to morphine. She got the order of these backwards. We just discussed that NO3 polyatomic ion.
Stoichiometry.
He's there. He's almost there. If you say it 10 times, that's pretty difficult. Stoichiometry. That's a lot. Stoichiometry. That's close enough.
Stoichiometry is based on the law of conservation of mass. Recall from chapter 3 that the law states that matter is neither created nor destroyed in a chemical reaction. In any chemical reaction, the amount of matter matter present at the end of the reaction is the same as the amount of matter present at the beginning. Therefore, the mass of the reactants equals the mass of the products. Note the reaction of powdered iron Fe with oxygen O2 shown in figure 11.
Two and six, and then after we have 2 and 2 and 4. And why would we have this over here in this after? What is this called? This is called one word. It starts with an E. No. Let's say you're at like the pizza store making pizza, right? And you have enough dough to make 10 pizzas, but they order only one pizza. You're gonna have extra dough. What's that called? Excess or extra. So that will show up in your products. You're basically, you're gonna, if it's not used up in the reactants, it's gonna be there. Factors, mass to mass, and they want you to put them in order to where you get the atoms of C. Can anybody come up here and do this? All right. Actually, the mole is gonna go at the bottom, so because you got mole times mole, there is mole squared. See what I'm saying?
Yeah, I got you.
So think along the lines of meter times meter is meter squared. If you can just memorize one concept, that'll play out for if you're going to go in and do like
because you can always multiply.
any type of installation, like if you're going to install carpet, they'll measure 2 dimensions and it'll be like square foot. Not 12.
You're right.
Mole of carbon.
Would it still be moles of carbon?
That's hydrogen. Now, what's your formula going to be?
What I write in like counted it up. But it would be 3.
Very good. So the DEA has found a large quantity of powder and the people are resisting arrest. So we have to do every test known to science to make sure we have this chemical that is associated with morphine. Right? And once we've proven that, you go into court beyond a reasonable doubt. Does everybody understand beyond a reasonable doubt? Beyond a reasonable doubt is always more than one test. Just one test alone is not going to give you beyond a reasonable doubt. Multiple tests will. So how are we going to get these into percents? Trying to solve for that morphine formula. The reaction you have before 3N2 and after you have 2N2. Now this is the reason why we have something called a recipe. If you go to, let's say, a restaurant, they'll ask you to follow the recipe because they don't want you putting what onto the food or onto whatever you're making. No, it starts with an E. Excess. So if you put too much on the product or whatever you're making, right, you're not going to have enough to make the required, I guess you would say, meals that the recipe calls for. So every restaurant or every manufacturing company has a recipe they're following. In chemistry, we call that the balanced equation.
Oxygen is 18, right?
16. Water is 18. Good question. And then what's the formula going to be? So nice. Good job. Let's say that Gabriella, she's part of the DEA. She's going to take Brendan to court for trafficking morphine, right? And Lily, she's our prosecutor. What do you have to prove, Lily, to the court? Beyond a what? Beyond a reasonable doubt. So one test typically is not enough to do that. So you have to do multiple tests. So up here, we've tested the morphine and we found that we have 17.9 grams of carbon, 1.68 grams of hydrogen, 4.225 grams of oxygen, and 1.228 grams of nitrogen. We want to know what the formula for it is. The formula will tell us what this substance is. If it turns to be out to be a formula for like baking soda, then Brendan, you're off the hook.
Disappeared as you added sodium, hydrogen, and sulfide. If you concluded that the potassium per non-kit had been used up in the reaction and stopped, you are right. Chemical reactions stop when one of the reactions is used up. When planned, the reaction of potassium permanganate.
Why do we have this nitrogen in the products? Now, if you go to the workplace and you like add too much of a substance in the recipe to whatever you're trying to make, what do you call that now? Like if you're making a pizza, right, and it calls for pepperoni, and you put like 600 pieces of pepperoni on that, what have you done to the pizza? No, you've put excess pepperoni on the pizza. Do you understand? Now, the customer probably doesn't want that much pepperoni. 600 pieces of pepperoni is a lot. So this is called excess. Now, the problem with that, Brendan, Lily, the problem with wasting materials would be what? What's the problem with wasting materials, Lily? Well, one day when you do that and they fire you, then you'll know.
Would this be 3 or would be 2?
Yeah, this is right. That's going to be a 3. 2.9, you're going to round that. Good job. I'm proud of you guys.
The only thing that
We
you
did
can
it together. I know, you all are awesome.
Because I'm smart like that, sort of.
Oh, wait.
This would be,
That was for this one, my bad.
I mean,
That's the same thing.
same
Close
thing.
enough.
Hey,
Yeah.
Sergeant, can I get my homework?
Okay,
Yeah.
then it'd be C3, H3, and 0. I mean, O. And then just put a box in it.
Nice job. And then the next one, mole H.
Come on. No, that's
You know what you're going to do next now? What do you do now? No, you're going to divide all of them by the smallest number. Which one is the smallest number? So you have to divide all 3 of them by 1.8. Yes. 1.0. And then you've got the hydrogen and or carbon to do. Very good. Stoichiometry, 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 stoichiometry. Very good.
Products formed by chemical reaction is called stoichiometry. Stoichiometry is based on the law of conservation of mass. Recall from chapter 3 that the law states that matter is neither created nor destroyed in a chemical